All right. Let's do the tweeting. Make sure everyone knows. And let people chime in. All right. So today we wanted to it's a very informal session. Like we wanted to go a bit like over some of the recent stuff that has happened on our end in terms of the whole CI thing, a lot of the stuff that we launched on launch week, but mostly focusing on what is going on the NX Cloud side, on nx.app basically. And we want to go a bit through various things. So want to kind of bit like explain what are the main challenges of CI, why it's kind of important. I also have a small sample product set up here where we can potentially go through, kind of see how the setup looks like, or what it means actually to kind of connect such an NX workspace to NX Cloud and get it running there. But that just at a high level. Before we jump right in, for those that might not know us, for new folks watching, can you introduce you quickly yourself, Victor?
Okay, sure. So my name is Victor, and I'm one of the co-founders of NX, and I've been working on NX for 7.5 years. And prior to that, I was at Google on the Angular team.
Doing monorepos there. Or at least
monorepos everywhere.
Monorepos there.
That's right.
Monorepos everywhere.
That's right.
If you're at Google, that's kind of the default.
That's right.
Cool. Yeah, my name is Yuri. I'm at NX already for quite a long time. Been using NX itself even before that, and right now, or lately, last 1.5, 2 years almost now, I'm doing a lot of content around NX, educational stuff, and doing stuff like what we do right now. So doing some live streaming. Cool. Hey, folks on the chat. I see some folks already chiming in. One of the I prepped some questions to go through just to make sure we cover some of the points that people are most interested in. We just had a webinar last week, which, by the way, follow us on Twitter and NX, Twitter, X, LinkedIn, whatever you call these, because we started doing more and more such webinars, which are very focused on one topic. You can register for them. We will get the recordings afterwards. And they're I would say a little bit more formal than these live streams that we do here on YouTube, where it's more structured presentation, like a talk, and then you can chime in with Q&A. But we had a lot of folks joining last time, around 50, 60 people. So next time, definitely make sure you chime by or look out for some of the opportunities that come up. But I think before we start right away, we have, whenever we talk about things that we produce, that is NX, and then there's NX Cloud, right? And even our tagline on our webpage now mentions fast, smart monorepos, fast CI, right? So can you try just explain roughly what is NX, what is NX Cloud, where's the boundary, what are the differences, just so people kind of know what we're talking about.
Yeah, of course. Yeah, so the idea is, and that way it's a bit tricky. Generally speaking, there is a clear boundary. So when we use the word NX, we often mean the open source MIT licensed monorepo build tool, right? That you can use to manage your repo, to build apps, scale stuff, to make sure your organization works effectively, so you can share code and all this stuff, right? So this is the open source build tool that works locally on everyone's machine, can look on CI as well, but generally speaking, it's runs on the machine you run the build tool on, all right? When we use the word NX Cloud, we mean the cloud, or the other component for the build tool that lets you achieve fast CI, and in general, not just fast CI. We focus on fast CI in here because speed is important, right? But also resilient CI, for example. Resilience, and this is what I might talk today about. Resilience is very important, right? And CI that's easy to understand, etc., right? So that's the second part, the CI part. Then, and the way we think about it, that the build tool we have can be used with any CI product, right? But it's greatly enhanced by NX Cloud because it makes the NX build tool shine in CI. Suddenly things are much faster, much simpler, much more resilient, and whatnot, right? So that's a distinction. If you use NX only locally using the build tool, you just use NX. The moment you connect to shared cache, distribution, GitHub integration, you're using part of what's called NX Cloud, right? For other folks, there is also a Next Enterprise, which we usually refer like a Next Cloud distribution for enterprises, right? So that's kind of the other bit for the few who are interested.
So Annex Enterprise would be like the more like on-prem installation part, like the more.
It doesn't have to be on-prem. So, in generally speaking, you could run like there are different ways to run Nextcloud. For most people who use a Nextcloud, would use our sort of multi-tenant, typical SaaS version of it. That would connect to it from their workspace, and they would talk to that instance, when they run stuff in CI locally. Right? But if you are like a bigger company or company with certain constraints, right, and you want to have more control how your CI runs, right, you would go with an Next Enterprise. People would run, for example, a single tenant cluster for you, and where everything is yours, customized to your needs and whatnot, and more things are available for you. Or on-prem is another example. If you are, basically a bank, right? Then you need everything to run on-prem.
If you have like special restrictions, obviously like security restrictions stuff.
Right.
Even I think like folks in the EU, like which were like there's a lot of GDPR privacy concerns and stuff where you need to know where servers are running. I think we have dedicated EU servers. Though, right?
They don't have to use like enterprise. There is a dedicated EU SaaS cluster where everything is stored over there. For over there, it's where you are. You're right. So
where I am, yeah.
Yeah. So I'm in Canada, so I'm in North America. You're in Europe, right? So like that case, you don't have to go enterprise to to collocate your data.
I could go via those servers.
Right.
It's like more important than a lot of people think. Like it's just simply a restriction here. It is posed on your company, even if you wouldn't want to go different, right? So
that's right.
So being in the EU, like that's a thing that immediately comes to your mind when you hear cloud. It is like that. By now. So for folks, like just to like orient yourself a bit, like so nx.dev, this is like where you usually jump in. Like we share a lot of links that where you go to here, and this is like the open source MIT licensed thing. Like that's your tool that you can use for monorepos setup. Not only actually like you use it for single projects, workspaces.
That's right.
But that is what you usually start with. And then we integrate a bunch of things even here. If you go to the docs, like you will see there's a go to app link, and that will bring you over to NX Cloud, which is kind of like the thing that just Victor talked about, so the more CI focused part. We might even start kind of merging some of these things because like we want to, like the whole point of the tagline since we changed that, I think half a year ago, was actually to kind of signal how we can easily integrate, how we want to have that end-to-end experience, right, from front to back.
That's to me, I think it's one of the biggest lessons from Google and other companies. If you don't think of your build tool and your CI as separate things, but think of them as being like one thing or like two things that are synergizing or whatever, right? Suddenly a lot of nicer things follow, right? A lot of hard problems become easy. That's often the case in software engineering in general. If you reframe something in a different way, suddenly hard things become easy and you can go way further, right? Without having any difficulties. So that's kind of the thing we're doing, which is analogous to what a lot of big tech companies are doing as well. Saying, well, if your build tool and your CI are aware of each other, your experience is just much better. All right.
I mean that's the whole point behind it. Someone mentioning liking the blue, white, red color theme of our homepage. Kudos to Ben. Like Ben is behind a lot of these things. He's like our brain when it comes to making things look good, like from a design perspective, 100%. But hooking a bit into that point, like that you mentioned before, like the fact that you want that end-to-end integration kind of, and that you should kind of think as a whole from like the monorepo side locally to the kind of distribution on the CI side. What are the big challenges when it comes to CI and monorepos? Like what are the major issues people are usually hitting? Because like that is kind of to understand, like even why would you even want this? Like why do you need this, right?
No, 100%. So let me actually try to present. People who work with me know that I obsess with presenting things, and let me know if you could see it. I mean, I know if you could see it.
All right, here we go.
So here you go. So the idea is that basically the whole history of CI is very short, right? So it's about 20 years of of CI history. The first versions of cruise control, like 2001 ish, right? And so we look at like 20, and in 20 years, lots of things have changed in CI, right? We primarily we evolved in where the CI configuration is written. Used to be in the UI, now it's like in your source code, and how it is written. It used to be some weird form right, in Jenkins, whatever, or Hudson, right? Now it's like usually some JSON YAML kind of thing, right? And that's cool. But the mental model of how CI works actually didn't change, and it works like this usually. So you have several VMs, right? People can refer like CI systems refer to them in a different way, but let's say jobs or something like that. But essentially VMs, right? Those VMs run, and let's say it's like this. This is the most like typical example, right? And those VMs run, and each VM executes a series of steps. It's basically a virtual machine, like a computer, right? And this will be like a plain VM. It figures out what needs to happen, and it does like it executes a series of steps. And then once it's done, it sends some data, usually using some envars, some other things, right, to these VMs. And this can run builds, this can run tests, and this can run more tests. Test too, right? Some more tests, right? And each of those VMs over here will run a series of steps to set up the VM, like npm install cache, yada yada, Gradle, etc. Right? And then it would run some verification steps, like run some tests, run some builds, right? And once all of them are done, it goes over here, right? So this is generally speaking like how CI works 90% of the time. Not always, there are systems that are different, but the majority of mainstream CI providers do this, right? And that is like a distributed execution process. As you can see, there are multiple nodes. They have to exchange data, or these arrows point out data, right? It's distributed, and they have to have a certain degree of like fault tolerance. Right? When one of those VMs fail in some way, what should happen, right? This is a very poorly written, usually, distributed execution process, right? Why? Because there is no fault tolerance. If this test 2 fails for whatever reason, let's say npm install fails to materialize, or fails in a soft way, it just suddenly runs very slow. It's a soft failure, right? Because if you as a core team guaranteeing that CI runs in under 30 minutes, and suddenly you have this 50-minute runs once in a while because one of those things just maybe runs out of memory or God knows what, right? It just doesn't perform well enough, right? It's a soft failure. You're in trouble, right? And so they don't tolerate failure at all, and they secondly cannot really communicate. This arrow looks impressive, but in reality, it's super hard to send anything from one to another one, and it's usually like even if you send files, it's like huge amount of work, right? And people don't tend to do it. And it happens usually once at the end of the whole thing. Like my VM is done. Okay, I upload some files. That the next one.
Yeah, it's the usual uploading and downloading of the cache artifacts. Basically, which you have like the file system level, basically. Yeah.
But it's very hard. So if you think about anything like I need to build it to test it, suddenly it becomes like super hard. All right. There are other problems in here. Each of those VMs have to run this init steps that are slow. So now I do them in order. This is like 5 minutes and 5 minutes and 5 minutes. Like lots of problems set up. So you have like 15 minutes of fixed cost. Any failure breaks the whole CI, etc., etc. Right? And the issue gets worse and worse because the issue with the monorepo, the monorepos tend to be a bit bigger than non-monorepos. This model is this distributed CI execution process, poorly written. But if you have very few VMs, let's say 2 or 3, the poor written nature of it is still okay, right? Because it kind of the problem goes more and more the bigger your repo is, and the more VMs. It's like an exponent in a problem formula, right? So if you have like 3 VMs, okay, it kind of works okay. It's actually not a big of a deal, right? Not ideal, but it works fine. If you have like 10, okay, it's not already a big deal. If you have 50, okay, it doesn't work. It just doesn't work, right? So and for like a real huge repos can have more than 50, right? Obviously, but even like past 10, it becomes such an unworkable thing. It's just headache to manage, right? That's kind of the issue. That monorepos are a bit bigger. That's one problem. Therefore, you have to use distribution to make things fast. And therefore, you have other things. Like imagine, because using monorepo, you have a lot of end-to-end tests you want to run. You have many apps in there, and the probability of end-to-end test failing something like this: 1 in 1,000. The test will fail. All right. 1 in 1,000. It's actually a very good end-to-end test. Most end-to-end tests say way more than 1 in 1,000. Way more. This is a super robust test written by
it's a very optimistic approach. Yeah.
That's right. Written by the most brilliant engineers. Right. If you have 1,000 tests, you just need to multiply the probability, right, and say, well, it will be like what is this, like something like 0.999. This is a success. Power 1,000, like let's say 100 tests, right, and then -1. That will be kind of the formula for the success thing. Suddenly you're in a territory where like 20%, 30% of your CI, even with a relatively small repo, failed due to flaky test. And that's what we saw actually. The next repo is not a massive repo.
Yep.
About 17% of our end-to-end test run failed because of flaky test. Right? I used to fail before we fixed it in a way that I'll explain in a second. Right? So like if y was smaller by 20%, but the point is because it's an exponent, right? Suddenly you add when you try to you could say I will try to optimize this point. I will make my test super robust, indestructible. At some I don't think it's kind of possible, but you can go from this to this. It's possible. To this, it's basically not possible in practice. Something you have a complex system. It will fail for some reason. You just don't understand the reason sometimes, right? And PM installs fail. Lots of things could fail, right? So what we that's kind of the issue. Your repo grows more and more. You have more and more tests, more and more stuff, and the exponent part makes it substantially more likely for your CI to fail in a way that is kind of confusing, some flaky test basically, right? So that's the second problem on a monorepo and CI. And the third problem is that monorepos tend to vary in how much CI they want to run. All right. If you have a monorepo with, let's say, 100 packages, let's say 5 apps, 20 packages each or whatever, something, right? You can have realistically, I mean, it's unlikely you're going to test one package, but you can really have a 10x difference in the amount of CI compute you need to run. It's actually not crazy. That's normal. That's absolutely normal, right?
Yeah. There's
Where
a
you
lot
can
of
you can
up and down depending on what you change, like in
That's
the
right.
graph of
Exactly.
projects you might have in a monorepo. Yeah.
Exactly right. So like because you have a 10x difference, you cannot have a fixed number of VMs, and that's what most mainstream CIs are. Fixed number of VMs will almost always be really bad for anything but a trivial monorepo. Trivial monorepo, okay, you overpaying a bit because you're kind of accounting for the worst case scenario, right? But if you have a non-trivial monorepo and you're saying, well, sometimes I need 50 machines, but most of the time I need 10, and sometimes 3 is okay. If you always provision 50, that's just crazy town, right? That's like you're just paying, and like there are other things like emissions and whatnot. Like basically you're running too much compute, all right? So you just cannot do it. So you have to do something smart about it, right? And that's kind of the third problem. There are many other concerns with like just displaying data in a monorepo CI, but those are the three main problems.
Yeah. I think it's not even just like, I mean, the upscaling and downscaling really kind of goes in the direction of like also cost savings in the end, right? To be more efficient and not just like allocate always the same number of VMs.
Yep.
But I think like even like I just like thinking back like when we didn't have distribution or maybe even not NX Cloud, and we did work with clients and like set that up like manually. I remember projects like for instance GitLab where you can actually generate pipelines dynamically. But the problem is always like it's still very static because the moment you set it up, it might be optimal. But then, like, if you have lots of folks working on a monorepo, they change the product structure, move products around. Suddenly, like, you have much more tests, so you would need more balancing out all those tests on different machines. So it's always something you need to kind of keep up and like be continuously being working on it basically and fixing
That's right.
stuff.
You always like from what we see, like going from fine-tuned manual distribution to just using cloud for distributing with the same amount of compute. You're saying I'm going to use 20 agents all the time here, 20 agents all the time there. Not even the smart number of agents, just like fixed 20-20, right? Results in 30% improvement in clock time, right? Because just the allocation of things is better, right? This way. So yeah, like it's just very hard to do things manually, right? Where the system can probably do a better job automatically for you, right? Most of the time.
Yeah. Vato here asks, like, is there a way to get more granular component level affected results without creating libraries for each component?
The answer is no. And so this is it's an interesting question because the whole affected part to me is kind of secondary to cache. I think so. I think the cache is where the biggest gain is, right? Because if you look at the cache, like as long as the cache works, right? That's kind of what matters the most. And most of the time, with whatever issues people have with affected, at the moment they have remote cache, okay, things could be affected, will be remotely cached, and things are still very fast, right? You could implement a manual one because if you look at the project graph per return, we actually store which file dependencies for every file. So the project graph we have lists all the files with all of the dependencies in there. So one could build something custom for a particular case, right? The reason why we didn't is not because it's super hard necessarily. It just complicates things a little bit or quite a bit because it's sometimes you have files that implicitly affect this and that. Many things you end up being kind of in the tricky spot, right? Where you need to figure out which file is affecting what, right? And you can know for a particular case, you're saying, oh, I have a library written in framework, a particular framework, like an Angular library, a Vue library, right? And I know for a fact some constraint that I just know because I'm a domain, I'm working in a particular workspace, we use it in a particular way. Therefore, I could just assume many things, and things are kind of quite easy, right? But the moment you're saying it has to work for any file in any type of library for anything, then like, okay, that's much harder. All right, so
Yeah.
like it's one of
I
those
could
cases
totally
where,
see where you run into some weird edge cases, right? Which then
all right,
you kind of either mark something not affect when it should, which is really worse then because like then tests are not run and stuff like that. So
yeah,
I think
exactly.
right
So
now are
it's one of those things, yeah, where a specific solution is pretty possible. I'm not saying it's easy, but actually not that difficult. But the general solution is very hard. All right. So and confusing, just will be confusing for the user, right? And because you get most of the benefits via cache, like whatever, it's kind of
Mhm,
sort of
mhm,
solves a lot of like the problem a lot of the time.
mhm. I mean, the question is good though. Let me see. There's another follow up. Don't cache working on pipelines yet. I guess that's why I got the question. Not 100% sure what is meant here. Can you follow up? Can you give more
Yeah.
details around what is meant there? Because like the question actually is good because like one thing we did related to this is kind of the granular splitting of end-to-end tests, right? Because those are also
Yeah.
potentially a problem, and I think we could actually
Yeah.
look into
Yeah.
some code of what that looks like.
Yeah. Good idea.
So let me kind of quickly jump in. Let me actually just directly jump to the end-to-end test story because like that was kind of related to the question that was just brought up. Because end-to-end test, the problem there that we often saw, and also like in our case on the NX repo, is like you have those huge blocks that
Yeah.
like it's hard to split up. I mean, Cypress as well as Playwright now provide some component level testing. So people are attempting to split up projects into subdomains and stuff, but it's a lot of
Yeah.
manual work. And
Yeah.
so when we released Project Crystal, which is the ability to infer tasks from like a project JSON rather than actually you having to manually define all those tasks,
Yep.
we kind of almost like I think you brought it up, like it was almost by accident we
Yeah.
found that actually a Playwright as well as Cypress, we just implement it for those two for now, but like there's nothing that prevents you to implement that for
Yeah.
other
It's
tools
actually not hard to
potentially.
build it for a lot of other tools. Yeah.
Exactly. So we started with these two because like we saw that like you can actually provide a flag to these tools to run the end-to-end test just for a single spec file. And so given that we already generate those targets dynamically, we actually went ahead and generate them basically at the file level. So this is what you see here, like what I did here basically. I went into the project JSON and there's an icon up here. You can also kind of open it up here directly inline. And this is VS Code. Same thing works also like in WebStorm. This opens up the NX console plugin, which just lists basically all the targets that are available to run for this given project. And here I have a bunch of end-to-end tests in here. They're not actually very intelligent tests. They're actually just like copy and paste
Yeah.
the tests that check like what is like on
Yeah.
the website.
Yeah.
But just like to show, like here we have a bunch of tests here, and if we open it up, like again here in the project detail view, you can see that for
Right.
each of them, a test target got generated. And so this allows us now on CI to run them individually. And
Right.
we have seen some quite good gains there, right? Like we have some test projects which saw really good optimizations there.
Yeah. So that's like this is like worth stressing is that what you want really is an efficient allocation. What it gives many things. Like one of the things that it gives you is the ability to write like one enormous test suite that can take like 5 hours to run if you run it serially. But it doesn't matter because CI will never run it in like in order, like on one machine. It's going to look at the test, run them separately, right? Each test will be treated as a separate target. So if you have 20 machines, they are going to pull each test, right? So so the location will be dynamic. If some test is slow this time, no problem, right? The other test will be run by different machines. So the allocation is much nicer. If it's 5 hours, you just need to increase the number of machines, and you're going to see the end-to-end test phase go down to basically the slowest test, right? That's kind of the extreme, right? So that's the cool part, because before prior to the change, we would always tell people, well, you could split it, and we would have all these manual workarounds to essentially get a poor version of this. This is automatic, right? The thing that's worth noting that this only works, right? And that's where I think a lot of features kind of have to come together, and people don't see the a lot of the times when people ask for things, you're like, yes, we can get it, but there are 10 other things that have to happen before the experience is good. So for this, the experience is only good because those tests that run have to be able to serve you up very quickly. If they don't serve you up very quickly, then suddenly you're in trouble, right? Because now if you have like I don't know 500 tests, you don't want to serve the app 500 times. Great, right? So So like the static serving becomes a lot more important. Now you have
Yeah.
a way to serve something very quickly, such that you can have 20 agents running things, and there is very low overhead with that. Okay,
Yeah.
that
Yeah.
has to be basically built for everything. Thirdly, what this gives by itself, that's by really nice. We have this split, that distribute. By the way, we're making some changes to the UI to make this splittable test more nicely present in the UI, right? But this is coming in the next couple of weeks in prod. But so that happened. But what this enabled, and I think most people don't realize it, it enabled deflaking. Right? We used distributed compute before, right? And we always thought about detecting flaky tests and then running them, right, automatically. The issue, though, if you have large test suites, deflaking is very costly and it's not very useful, right? Because you have a 40-minute thing after you run, you're like, yeah, it kind of sucks still. You don't want to do it automatically, right? Because 40 minutes is a lot of minutes, right? If you do it automatically, that's a huge penalty, right? And for a lot of people, it wouldn't be acceptable. For some people, it would be, but for a lot of people, it wouldn't be. Right? You want to deflake a small unit, like take a minute to run or 2 minutes to run, right? Because or like 30 seconds to run, because that small unit then, but flaky, you can run it. If it happened to be a flaky test just fails for a legit reason, well, that's fine. You just spend another 30 seconds or another minute, not a
Yeah.
big deal, right? Of compute. It's much different what that enabled. Okay, now this 30-minute block or 1 hour block or 5 hour block became lots of 1 minute blocks that allow us to rerun that 1 minute block many times if we feel like it's flaky. So those things will all stack together. Static serving has to happen. Crypto had to
Yeah.
happen. Then this appeared. Then it enables this, and now it kind of all unfolds in the experience, which is quite nice, where you can drop an X into any major like any repo with all of Cypress or Playwright tests, and they are no longer they are become basically super fast and not flaky, right?
Mm-hmm.
Like
There,
robust.
there's
You
some
know,
good there's some good points that you mentioned here. I just want to make sure that people understand why this is a problem, right? Like this is basically what we talked about. So you have
yeah,
this single block. This is basically a distribution problem, which this one is hard to distribute because that single block is hard to
yeah,
rerun automatically because you, as you said, like you would rerun that 40-minute block again, which doesn't give a whole lot of value. So what that splitting here that we saw just before here allows you to do is basically move from something like this into those fine-grained ones.
yeah.
These can then be distributed much more evenly across these machines, right? And so
That's
now
right.
you would rerun just one of these single ones that fails,
Yeah,
and ideally you wouldn't even notice, right? So it happens automatically.
yeah. You
We
will
can maybe
notice
have a
that.
look at that.
Yeah, that's the whole
Um,
point. That you just don't care about flaky tests anymore.
you should
It
notice.
lets
It
you.
just passes
Yeah,
and go ahead,
it just
basically.
works, right? It's like when
Yeah.
you with like a safety features on devices, like when one thing fails, something else has to kick in, but you shouldn't be like, it just works. You can retroactively look at it and do something about it, but in a moment things just always work. That's the idea.
Yeah. Yeah, exactly. And the next big point, that is actually a question that has come up also from the community over different channels in the past that you mentioned, is that the fast serving.
Yeah,
And we have we have a target defined here, serve static, which does nothing else than pre-build your app and serve with a static HTTP server. That's it.
yep.
And
Mhm.
advantage there that people kind of don't see immediately is that these are basically our machines, our agents, right? That
Yeah,
run in the background where the tasks are being run. They all have access to that cache. Now, if the build
yeah,
is cached, that build has happened before these tests run,
that's
ideally.
right.
Like that's
Yeah,
what we make sure. Like that's also why the distribution kind of is a bit more intelligent than just naive splitting across machines, right?
yeah,
The
that's
thing
right.
is, like, once these end-to-end start running, that build is already basically ready, right? So it just distributes across these machines. So from that cache directly to the other machines where it's needed, and the static HTTP server just runs it, right? So these
Yeah,
artifacts are being transferred there. That has been a question that has come up, like I think in one of our YouTube videos, where people were like wondering, but what does that mean? Like, do I have to spin up my web server on each of these agents each of these times? No, clearly, no, you shouldn't, right? Or
that's right.
that would make it
Yeah.
slow again.
Yeah,
But
exactly.
that's
So
being
the whole
captured.
point of like, if you imagine your build of your app can take like 10 minutes, even in dev mode, right? You for sure don't want to run it on every of your agents, because 10 minutes, even if it's once per agent, it's still 10 minutes, right? 10 minutes is a lot
Yep,
of minutes.
yep,
So instead, what you want to do, build it once on one of the agents in 10 minutes, while the other 9 agents, for example, are testing and linting unit test stuff while the build is there. The moment build is ready, you're like, okay, now you can run it run tests, right? Because you have this. That's kind of the idea. You don't want to be running this 10-minute thing on all 10 of them, because that's just silly, right? You want to do
yep.
it only once, and while this one machine is working through that, all other compute that's not blocking it has to happen, right? So what is going to happen soonish? Currently, we don't have it, but it's coming. It's coming in, soonish, right? is that currently when we give you like say 10 agents, it's 10 agents. So if you have a very slow build, okay, the other 9 agents could do all the tests and lints, but this one can still be kind of blocking the whole thing, right? What's coming soon is that of our ability using AI and whatnot to predict the flow of how many machines you need through SCI execution, so we could know allocate less at first because you or fewer machines at first because you know like this slow build and then there it's not super, but once 10 minutes in, throw a few more machines proactively, right? Because end-to-end tests will be available, and those things will take 3 hours, and they're easily parallelizable with the new features. So start from 5 machines and go to 20, right? Sort of thing, right? And that
In the
would let
same
you
CI run, right?
yeah, in the same
In the
CI
same
run,
CI
where it's
run,
like
it's kind of like
yeah, exactly, because we know you don't need it at first. Don't give you just a little bit. Once you need them prior, the machines will be ready, and that would let you save more on compute. You no longer need 20 machines throughout, let's say, a 30-minute run. You need 10 machines the first half of the run, and 30 machines the second half of the run. So you get much better performance and efficiency this way.
Let me bring up a question here before we dive into some code that shows how to do that. So Lauren asks here, in your experience with enterprise customers and large monorepos, do you see people running all affected end-to-end tests before merging PRs or deferring slow tests to post-merge tasks? That's an interesting one.
Yeah,
Because
so
that is exactly, I think, what happens often, right? Like if it's
yeah,
slow, you
yeah,
move to nightly, to weekly.
yeah.
Like ultimately,
And I
don't
think
run anything.
partially it might be like I'm not saying moving things to nightly is always a bad idea. Sometimes it is a good idea if you're saying, well, it's something that is likely to be unaffected by my PR, fails very rarely, right? Maybe running it more frequently is too much compute. Even if you do it smartly, like compute is still compute, right? Perhaps you don't want it, right? Because you could throw enough machines, it will be fast. That's not an issue, right? If you throw enough machines, things will be fast, right? It's more like a necessary compute, right? That you don't want to run, right? For many reasons, cost, environment and whatnot, right?
Yeah.
But I think a lot of the times what people switch to like running things more rarely or nightly is not because they are preoccupied with compute, right? They're actually okay with the amount of compute spent or the financial things that are happening there. It's like because the number of tests is the exponent in the flakiness formula, right? Plus some number, the things are not going to work. This is the
Yeah.
reality, right? So that's why people abandon us. So they say like, well, we have it is always flaky. Like, no, but if you fix flakiness categorically, which I mentioned before, then it's not a problem, right? So what's your concern then, right? If your issue is flaky end-to-end test and you can fix flakiness categorically, that is not a problem. But if you don't fix flakiness categorically and that exponent grows, you could see that once you go to a certain number of agents, let's say 20, 30, 50 agents, about 70% of your builds are going to fail for flaky reasons, unless you do something about it, right? So now you're saying, okay, like every second time I run something, there is a flaky test, right? That
Yeah.
fails, at least one of them, that fails the whole thing, right? And so I cannot really manage it. So then the answer is, okay, let's run a smaller subset and run some larger set nightly. A nightly will always fail. That's the reality. It will always fail, but because it's not blocking anything, people will look and say, that failure is a flaky failure. Like a human being is going to assess and say, it's always red, but they know what is a real red and what is like it's meant to be green, but it happened to be red, right? And that's what I often see in nightly. It's like they're continuously failing, and the human being just assesses whether the failure is a legit failure or like a flaky failure kind of thing, right? And so once you categorically fix flakiness, when you're saying end-to-end tests are categorically fast given the right number of machines and just cannot be flaky essentially, because you run them, we can talk about how we run them, but we run them on different agents to reduce, blah blah blah, to make sure things get deflated, right? Once you solve that, you can decide more strategically. Just saying, you know what, I just don't want to run this much compute, right?
Yeah.
It's not about
Yeah.
flakiness when you say no speed, because you can get both. You can get both robust and speed, fast tests by just allocating enough resources, enough agents, right? But you could say, you know what, I just don't want to run compute. It's it's money, it's other things. Let's just run a different set nightly, right? But it lets you kind of have a different point in the decision where it's like you want to run nightly, maybe things in different browsers that never fail, but just in 1 million chance it might fail, and that would be the thing, right? And the nightly builds in this case, you also want to deflake and whatnot, such that they always
Yeah.
green as well, right?
Yeah.
So that's kind of the thing. But yes, everyone pushes to because essentially with the formula plus some number of tests, like a few hundred end-to-end tests in individual tests, right? It's just you just cannot work. It's just like the thing that doesn't work anymore, right? It's so unstable that it becomes crazy. Right? That's one of the arguments against monorepos as well, because again, same thing, right? They're saying, well, the things always fail, but if I have my own repo, then the number of tests is not 500 but 50, and therefore only 5% or 10% of my CI builds fail because of flaking is more manageable. But you could say, how about it's not 10% or 50%, it's zero. And the moment it's zero, okay, the target goes away. Right?
Yeah. For me, pushing back to nightly is always like, as you said, like if it's intentional or if it's something you shouldn't be super worried about, like if something fails, well, that's okay, right? But like usually, once you push to nightly, it gets out of your sight, it gets out of like, that step further away from the feedback cycle, and like no one will look at it. Like 3 days later,
right.
Oh, the nightly's failed. We should have seen that, and that's why the product failed in prod or something, right?
Yeah, exactly.
But yeah, very very legit question. Like that is one of the reasons. Like also one of the big pain points. Like when you run end-to-end and stuff. Exactly. I want to pull in another question before we jump into some coding. Vato asks again: is there a way to set up on-prem NX Cloud free version limited for enterprise? I don't think so, but like based on this one, like we're actually currently running a promo on our. Let me bring in here the browser again. Like if you go to nx.app, right, you can currently sign up for a promo that we're running, which gives you, I think, 2 months free within the limits, right, Victor? So for the startup, the pro plan. And so there you can actually test it with our NX Cloud infrastructure for like good 2 months on your actual code base, right? So I think that would be the best way, because like then you're making sure you have like both the remote caching, you have the NX agent distribution, everything in there, so you can best evaluate basically whether that is like beneficial for your company or doesn't give you all the benefit just now because like the workspace is not large enough or whatever, right? So definitely check that out. I will drop some links later also in the chat. But yeah, like I wanted to just quickly go in, and we can keep talking and afterwards because like the setup will take probably some time. Like how do we actually connect a workspace to NX Cloud? Because right now this is not connected. The only thing I did already, just like to save us some time, is to set up a CI script. And this is a generated one. Like this is a super simple one, clearly. Like yours is very likely more complex. But you can, for instance, generate this one with the NX Workspace CI workflow generator. And this will give you options for generating, I think, for GitHub, Circus, Azure, Bitbucket pipelines, and GitLab.
Right.
And it will give you a good starting point, and then you will fill in clearly the rest of it. But just at a high level, I think this is interesting to just see what is going on. Like this is all the CI script that we have. And this is the whole distribution command that you need to do right now. So this is basically, while you would have multiple of these steps below here to set up like multiple machines in parallel, depending on the CI provider, this is across CI providers. That's the line, right? You're basically telling NX Cloud, start monitoring a CI run, distribute it on that many agents. Like in this case, it is a fixed number of agents, but you could also have that per PR size. We can maybe look at that quickly afterwards. So right now here we're saying like just distribute on 5 machines of this type, which is like a specific type of having like it's on Linux, it's like medium kind of compute power wise and JavaScript focused. And then we just do the usual stuff that we would do, right? So running npm installs. Here this is like specifically for running effective commands to make sure we grab the latest successful run, not just the previous one, which often can lead to some wrong outputs, wrong outcomes. And then you run your commands. And here I run many just to make sure we run all the commands, so I don't have to keep chaining stuff. But clearly here you would probably have something like affected, right? As you mentioned before. So you would have something affected, and that would then kind of make sure you just run those projects that actually you touched in that PR. So to set this up, what I'm going to do is create a new repo. I push that to GitHub. Actually, let me name this differently. Get this set up, and then we can go and connect this to NX Cloud. Now, let's see how this goes today, because last time on the stream, StreamYard actually blocked all my connectivity, so I wasn't even able to do a git push, so we'll see how that works. One thing while this is pushing up, I wanted to ask, is what are some requirements for running tasks on these agents? Because clearly, what we do here is we run it through NX, right? So like
Yeah,
NX knows how to run these things, so we don't have to go give low-level instructions of how to build stuff, because that's kind
right.
of encoded in one of these tasks. What are some other prerequisites of like being able to run it on agents? Like, can you run any task or?
Yeah, anything can run on an agent. Anything that runs via an X can run on an agent. So when you run a build, run menu, affected, it actually doesn't matter. All of those are like basically whether you run one thing, menu or affected, the same thing. Really, underneath, you just like there is a wrapper selecting which part, which projects will be like the root of the computation, right? And the whole the same thing will happen, right? If you want to run on agents, right? Uh, when you invoke start CRN as you do, uh, uh, every command that you invoke via next would say, okay, now instead of running all the tasks locally, it's going to submit the task graph to our next cloud, like either the SaaS version or the prem version or whatever,
Yeah.
right? And next cloud and say, okay, I have this task graph, and it's going to, the start CRM is going to spawn the right number of agents, right, that you specify, or based on that, like either static or dynamic, depending on what you configure,
Mm-hmm.
right?
Mm-hmm.
And then those agents are going to be like, I'm available to run any tasks. What would I do? And the orchestrator will say, oh, I see this task graph. This line is like a blocking line. Let's start with this one and start pushing tasks to the agents, and the other agents will pick it up. The task from an X point of view, that's just an X point of view, not nothing to do with distribution, is simply a process wrapped with known inputs and outputs. Inputs meaning
Yeah.
that it knows what affected such as the compute the cache, and the output, it knows which files are going to be created such that an X can grab those files, right, and store it in cache or move it to a different agent, right? So any process, right? Whatever you run, it doesn't matter as long as you
It needs to be
specify it.
cacheable though, right? Does it?
It needs
Like
to be cacheable. That it needs to be
because that's kind
cacheable
of the
because
transfer mechanism between the machines
that's
that
right.
we
It needs to
use.
be because the reason why it needs to be cacheable, what a cacheable task in NX is essentially is a task that could be replayed, meaning that it creates an output. You could replace the whole task with just that set of outputs. All right. So that
Mm-hmm.
allows for distribution. If you're saying I have a build, but something else depends on the build, if you're saying the only result of build are the status code of the process, the terminal output, and the files, all of those three
Mm-hmm.
can be stored and replayed on a different machine, and the effect is the same. That's cacheable. If you have
Mm-hmm.
something
Mm-hmm.
else that the process does, for example, you're saying, okay, my process does this, but it also opens a HTTP server locally and it keeps it open. Okay, that cannot be replayed. You just have to run HTTP
Yeah,
server
clearly,
again.
because
Yeah,
yeah.
so that's why it's cacheable. Fundamentally, cacheable is the same as distributable. Right? It means that the artifacts of your execution, of a task execution, is just set of files with a bunch of other metadata that can be pushed around. Right?
Mm-hmm.
So yes,
Mm-hmm.
so anything you run which create files and create some status codes like test, like like test failures, and creates terminal output, could be distributed. All right, very easily.
Cool.
And with things like Crystal, which you mentioned, it's also possible to write it such that it's dynamically distribute, like split one unit that you think as one piece into multiple units. Right.
Yeah.
But the
Yeah.
example would be like you say you have Gradle, right? Not there's nothing JavaScript about it. You just have a Gradle project. You hit the Gradle plugin that we use internally. The Gradle plugin is going to look at your Gradle files and be like, I understood. It knows how to distribute Gradle stuff, across the same agents, right? Without you having to do anything. It just knows based on the information from Gradle, right? So, but anything can be distributed. That is
Mm-hmm.
cacheable. That's it. That doesn't create other side effects.
Cool. So meanwhile, I pushed it up on GitHub. It looks like I have to stop screen sharing and for Git to work for some reason. So what I have, like, I basically went to nx.app here. That's kind of like you can connect in different ways. You can also run nx connect locally to get the
Yeah.
setup done in your machine, or you have it like already somewhere on GitHub, like you haven't it created just right now as we did, obviously, like in this demo, but you have it already, so you can just directly log in, create an organization if you have none yet. Once you have an organization, you can connect a new workspace. And that's what I'm doing here. So basically to the question also before for testing is I'm also here on a pro trial on my account here, where I can basically test this out for free. You don't have to give a credit card or anything. So this is probably the best way to check it out right now. So I'm going here with the connect GitHub flow, where I can directly read the GitHub repositories that I'm connected to with my account that I provided here on Nextcloud.
Okay. Let's hope your GitHub replies to you.
Yeah, let me actually. I recently had some issue also, like in another stream I was participating last week, that when I'm screen sharing, my connection gets super slow. Like it's like StreamYard sucks everything up. Let me just remove me from screen sharing right now. See where it goes. Otherwise, you need to jump over and connect it to your workspace.
I can quickly talk about one of the issues with flakiness we had that we managed to address. Because I think it's one of those things that a lot of enterprises do have, right? And uh, they try to battle it by being perfect, and it kind of doesn't work, right? So anyway, so the issue we had, so we had a bunch of end-to-end tests, and our end-to-end test rely on a database because it's like proper end-to-end. We don't just test front end, we test front end combination with API and the whole thing, right? So that it all works, right? And so we had this thing, and one of the issues we had is that because it relies on a database, the test meant to clean up the database after they run, such that the things work perfectly, right? Like you can run tests in any order or whatever. But anything that is meant to clean up the database, I guarantee you won't do it perfectly, unless you kill the DB and start from scratch and refill the fixtures. Like you can make it super slow to work, right? But otherwise it won't, right? So we had those issues where once we start, like once tests are splittable, right, and like once you run enough tests, basically, the combination tests could be different, right? And you could have a case where some other test leaves something in the DB or just fails and doesn't clean up the DB correctly or whatever. And you have this like leftover artifacts in DBs. And then when you run selects and you test, wrong number of records and return or whatever, right? And you could say the answer from like a mustache, to an architect would be like, well, you should write things correctly, right? Like if you write things correctly with a DB, is this and that thing is this and that, and you clean up this and that, and it's like that to me is the most irritating answer. It's like people are trying to run things correctly. We're not idiots, right? So we're trying to do things well. Most enterprise organizations, like not all of them, but not most of them, all of them, I had a chance interacting with, have super smart engineers who are not idiots, very smart people. It's just hard, okay? So when things are very hard, you cannot just tell, how about you do better? It's like at some point you're like, we're trying to do better, but things are still failing for bizarre reasons. Right? And the part that is interesting about the database part, that if the test fails, you just cannot rerun it on the same machine because the DB is corrupted unless again So our deflaking always runs the same test on a different machine. On an off chance that something else somewhere created some artifact that affects the test.
Some side effects.
Yeah, the answer is yes. You should still look at it sometimes and try to make sure your things are not completely like loose, but in practice, it happens all the time at any complex system. Right?
Yeah. Here now, meanwhile, like I went ahead, like connect my workspace, which created a PR here directly on my repo. And you can see here it directly hooks in a comment basically on my PR where you can jump over then to NXCloud. And here we see what is currently in progress, right? And you can also see down here, this is kind of like a visualization that we have where it shows like the main workflows that are running. Here is currently like running the lint testing and building of all apps. And you can see it distributing. Right now it's running here on this one agent 4, just right before we saw some more of these agents running. So it seems to be spinning up and down based on what is currently processing. On this side here, we won't see anything in here right now because it's a fresh repo, but this is like the remote caching, right? Which directly here feeds the NX agents. Here you can now see basically it's jumping over to end-to-end tests, and I run them in parallel one. So one test goes to one machine to kind of distribute all machines, just one single one. So we can nicely see the distribution. And you can see those 5 agents basically running right now, which are processing the tests.
Yeah.
One question that also came up like in the webinar last week is like, do we do anything to optimize node module installation between these agents? Do we do that already?
We do have like restoration like every other CI system, right? And the restoration is like, we know with node modules, like with permissions and all the jazz, we know, well, okay, this is the cache node modules, we're going to restore them. We do it also in a way where we only upload the node module, like because we're like, if you run 50 agents, you don't want to upload 50 of them, to only upload it once, etc. But so that part does work. So node modules are restored in a way the way we would do in Circle or whatever. That's why it's usually pretty speedy. The other part that's interesting in that what we this is already happening. So this is like we're doing normal things every other serious CI provider would do, right? We also have a launch template that we provision that already kind of configure everything correctly. It just works.
Yeah.
So it's kind of harder to misuse, which is easier to do with other CI providers. But one of the things that we are considering is have a warmed up agents. Basically, this is mostly for enterprise clients. Let's say you have an enterprise client. You know what, spawning my agent takes, I don't know, 1.5 minutes, or something like 1 minute, right? But you could say, well, what if you have a warmed up, like a pool of agents that have a particular version of node module? So let's say against main. So we run a PR. If your PR didn't change node modules, fantastic. Grab that agent, start running. Just clone the repo, like just mount basically that node modules in the right place. Things are running right away. And doing such optimizations for being able to speed up node module installation to a much, or like the agent spawning from worst case scenario here, like a couple of minutes. Usually it's faster, but a couple of minutes is realistic for it. Like if you change node modules, for example, to like 2 seconds, 5 seconds, right? Okay, that lets you to vary the number of agents a lot more dynamically, and it also lets for more interesting cases for local distribution. Is another thing that enterprise clients interested in, is being able to run command locally, like end-to-end tests that would then spawn agents, sort of like in CI, right? So that's a thing that could go way beyond any node modules optimization. That's just like you infinitely fast getting, or not infinitely fast, but reasonably fast, reasonably fast,
within the limits of physics.
Hyperbole. So within the limits of physics, but you get it very quickly, right? And so like in practice, it feels instant. You just get agents available with not modules with the right code that can run stuff. Where now what we're doing is what like just serious stuff that any other CI provider would do.
So yeah, like here to conclude the circle also, like I wanted to highlight a couple of things. Like this one succeeded, luckily. It went well. Like we ran a bunch of CI tests here. You can see down here, you see basically roughly the order of what's happening. This is like per agent, so see agent 0 to 5 to 4 basically. You can also click in if you want the details for a specific agent, which can be helpful like if something fails. But the more interesting part I feel is like once you go, for instance, on one of these where you see all of the single individual, here you see, for instance, like all of these distributed end-to-end tests that we mentioned before. So there's one per file that we distributed, and you can see for each of them what happened, right? So here this is like a playwright test, so they don't really log a lot, so it just like has the usual dots for each passing test. But this is actually useful because like in a single project repo, like you just run for one project, right? But here you have like hundreds of projects, so being able to filter for these types of things. And most importantly also, which I think comes a bit back to what we mentioned earlier, on our code base itself, all we did is kind of like just hook this in, run these commands.
That's right.
But you could have like further stuff down here, right? Like in a real world scenario, you upload resource, you deploy them somewhere. So what we actually do is not just distribute them on these agents and then it's kind of lost and you need to go into the individual agents to find your logs, but we play them back, right? So we play all the artifacts, the logs and everything back to your actual CI. And so if you go down here, for instance, you will see still your CI run, which was the main one that triggered the whole run. And if you go in here, you see all the commands that have been run, right? So if I open up here the end-to-end one, right, or the build one, regardless, you can see all the logs are still here, right? And all the files that potentially are produced by this, like a build that produced the dist folder, would be here, so you can grab it and do as if it was not distributed. And I think that is kind of a big
that's a killer feature. That's a killer feature because it like the fact that from the your CI main jobs point of view, GitHub Actions Circle, distribution didn't happen. From this like GitHub Actions will say everything is local, all the file, everything is there. So if you want to upload it to SonarQube for whatever reason, right, or other things, it is there, right? So it's not just you can go to a special screen and it applies generically. End-to-end test is just one part of it, but all of it is there. So the generality is a big part because there are solutions for splitting end-to-end tests right out there. We can argue how well they work, etc. But they are there. But the issue that the end-to-end test you split have to depend on build. So build has to be split as well. So all those things have to work in tandem for you to get the better results, right? The generality matters. And the fact that all the files are there mean that you can go from running CI on one machine to running CI on 10 machines literally within 5 minutes. All right? Without changing much. You slap one line at the top saying just start CI run, and that's about it. And that's a killer feature. The fact that you can enable distribution without changing the CI config, and just think of it as like I run it. You can even think about that. You run it locally, just much speedier. right? It just runs faster, right?
Yeah,
And
yeah.
to me, that's a big deal, right?
Yeah, you could just basically attach the other scripts that you already have. Because as we mentioned
That's
earlier,
right.
like this is like a simple sample one, right? But this could be in the middle of like your setup that you have to do for your specific workspace and
Yeah,
whatnot.
yeah,
Run the
exactly.
distribution and then afterwards pick everything up. And this is probably also an interesting point to hook into like the launch templates that you mentioned before, which you can see them here as well. Like you can click here.
Yeah,
This will give you the repo of what actually Linux medium or small JS means.
yeah,
And you could write these on your own, right? So if you, for
yeah, yeah.
instance, for
Very
now
easy
go
to write.
to like our NX repo, that's what we do there, right? So if
Yeah,
you go to the NX repo, we have actually here an agent's configuration, which is named Linux medium. And that's how we define like how that should look like, right?
yeah,
Pre-install some stuff and then use it within
yeah.
within
Ours can
the
actually be
flow.
simplified. It was written, before anyway. So,
A
but
while ago. Yeah,
yes,
yeah, that could
yeah,
totally
yeah.
be.
As with more things, what we have is like because we're early adopters ourselves. Okay, we need to really clean it up. But yes,
As dog
it's
fooding,
easy to.
basically, right?
Yeah, yeah.
It's always done
But
behind because like, you forgot to update.
yes, yeah,
Another interesting part here, just because I see it now, is also the dynamic change sets. So let me actually open up here our config file. And so in our config file here, let me make this a bit bigger probably. Because in our specific one, we as I mentioned when I set this up, like we just say 5 machines, that's it, right? But we have some sort of dynamic distribution already. So setting up machines based on your PR right now. So that's what we can do until like more fine-grained AI power distribution comes potentially. So instead of saying the machines here, you can actually point to a file, which in our case is that inside that .nx workflows
yeah,
dynamic change, that's folder. And if I open this one up, you can basically provide such categories. So you can say for small change set, I just want to run 8 machines, for a medium one, 10, and for a large one, 12. So this
yeah,
allows you to give some, basically, it allows you to give some tuning to the number of machines that you spin up. And as Victor mentioned initially, like we want to go much, much more fine-grained with this because
yeah,
these
yeah.
are even for the entire run, right? What would
That's
in
right.
our change, what would happen is like during the run, we would go up and down and the number of
Yeah, and that's
machines
plunging
how
soon.
it's
So
supposed to
we,
be.
I mean, rather soon as in
Soonish.
reasonably soon, soonish, right? Because one of the things you saw where like there's one agent that was finishing some build is an example of that. Where in the earlier stage, I mean, you have a small repo, so like, but at an earlier
Yeah.
stage, you need a few agents really because the build was the main thing, right? But at a later stage, for end-to-end tests, you need lots of things, right? So that's the kind of example where you probably want to like throw 3 agents at first and then bump it up to 6 or something like that, right? So
Mm-hmm. Mm-hmm. There's one question like specific to end-to-end tests. The things that for like depending on what you mean, like if you mean like for end-to-end tests in terms of how you run them with NX and how you can integrate that, like a lot of the docs are on nx.dev/ci for the CI specific stuff that we talked about. So you find all the things about how the affected works, how the remote caching distribution, task execution works with NX agents here, how the end-to-end test splitting works. I have like one with a nice thumbnail, which I
yeah.
invest a lot of effort into. Like
Yeah.
here you find the main things about like how these things work. Now the end-to-end test specifically, they're just you write them just as you would normally do with any
Yeah.
tool, right? So you basically go to the Cypress docs, you go to Playwright docs, you go to whatever tool you're using. That doesn't really change with NX, right? So that can be done directly on their docs.
Yeah.
Yeah, we're top of the hour. Want to be mindful of the time. Someone mentions NX is amazing, but unfortunately, with each release, there's a whole bunch of new bugs. That shouldn't happen. Definitely ping me. Like in general, I recommend folks like we have different resources where you can reach out to us. So obviously there's GitHub. Like NX is, as I mentioned, open source, MIT license, so you can directly go there. And there's also, if you go to nx.dev community, that's probably the easiest way to find those links. There's a Discord, right? There's the live YouTube streams that we have right now here. There's a Discord where you can chime in. There's a lot of folks hanging out there, answering questions that have difficulties or whatever, and helping out each other. And our core team is there as well. So we try to be there as much as we can to chime in, because it's also a good feedback cycle for us to kind of improve stuff or find out some more weirder edge case that we didn't think about when we kind of push out stuff. Cool. Just wanted to mention, because it was also brought up during the stream, I'm posting the link in the chat, our promo that we're currently running. So Chime into this one because this allows you to actually test it out on your workspace. So we on purpose increased the level of free credits you get basically when you sign up for this. And is the one for Pro. We also have a Pro for startups, which like smaller organizations or nonprofits, where you can kind of test out NX agents on your actual code base to see how much benefits you would get. And then you can reach out to us. Like there's like contact us link directly on the website where you can chime in and like talk to some engineers or some of our sales folks. All right. I'd say that's it. Lots of stuff, but people can obviously follow up with the recording. And yeah, thanks for joining, everyone. Thank you. See you next time. Bye.
Yeah, thanks so much, Fox. Thank you.